Hello, everyone. My name is Moacir Ponte. I'm an associate professor at USP, Universidade de São Paulo, and I'm here with Emílio Vital Brasil. Emílio? Oh, you have to unmute your.
Sorry, sorry. I'm Emilio Vitor Brazil. I work at IBM Research. I'm a senior researcher and manager, and today we'll be sharing the workshop of industry application.
Thanks, Emílio. So today we have a morning, at least here in Brazil, in the morning. This workshop of industry applications is a pleasure to be chair with Emilio of this workshop at CBGRAP 2021. And in order to show our program here, we are going to invite first Marcelo Siqueira, Vanessa Testoni, which will be our first invited talk. After Vanessa, we are going to have a paper presentation of our workshop, and afterwards, the invited talk from Marcelo Siqueira. First, we'd like to thank the program committee and the general chairs of the CBGRAP for inviting us to chair this workshop. Also thank all the supporters, such as Tech Academy, Apegs, CNPq, and SBC, URGS, and for being a support for this event. So without more delay here, we are having here Vanessa. Good morning, Vanessa.
Good morning. Good morning, everyone. So I hope you can hear me very well and that you are also able to see my first screen. And thanks for the invitation. I'm very happy to be here today in this industry-related workshop, especially because there is an audience that's so much familiar with so many topics that are related to the talk: AR, VR, MR, point clouds, light fields, a 6DoF, 3DoF. So I wanted to bring something new to the CBGRAP community today, something that's not related at all to any specific technology or any specific research area that you can find on papers or other sources. And then I thought of discussing some aspects of this new immersive word that we are so much waiting for and that are related to the industry point of view. So I hope that by the end of this talk, you will have some insights or even maybe answers for some questions that we hear all the time when we talk about immersive, this new immersive word, and that I've heard even this week during the conference. So for instance, why AR and VR are not mainstream yet? So we see some technologies, some applications already, but it's not everywhere as we expected it to be. Is it because of the headsets? They are too heavy, they are too uncomfortable, they are too expensive? Or is it because of the AR content? Maybe it's not good, or it's limited, or it's not compelling at all. So from my point of view, I can tell that the answer is yes for all of those questions, and the industry knows that for many years. But the reality is that there is so much more going on when a technology is turned into a real world product. So today we'll look at it. So I hope you find it interesting. I am the leader of the multimedia team here at Samsung Research Brazil. But today I'm actually speaking as the Brazilian head of delegation for the SC29 community. So don't worry if you don't know what it is. We will talk about it during this talk. But it's related with standards that everybody knows, such as Mpeg, JPEG, this type of standards. So I'm pretty sure everybody has heard about those. And we will talk about two areas that usually are not discussed in academia and not even in the industry in Brazil, which are international standards and patents, okay? So I have been working for more than 15 years in topics related with that, image processing, image streaming, especially image and video coding. But especially for the last 5 years, I got involved with this world of multimedia international standards, and I was able to learn a lot about how tech companies make the decisions of turning technologies into real-world products, and what is required, what is the ecosystem that's required for that, how they plan the future, like 10 years ahead. So today I hope I will be able to share some of those learning with you, and probably it's going to be interesting for everyone. So let's start by something that you already know about, right? What's your current situation? When we talk about video streaming, we already know that video streaming is the #1 activity in smartphone. And while video is also the most used form of communication. So I always like to look at numbers, right? So when you look at the Cisco forecast, for instance, the Cisco forecast for 2021 was that we would have around 3 trillion gigabytes in our networks per year. The forecast also said that by 2021, we would have 82% of all internet traffic consistent of video. And it means that at every second, we would have 1 million minutes of video that would cross our networks. And then we had the pandemic, right? So everything changed. And this only confirmed how much we currently rely on video. So it's not only for entertainment anymore. It's not just about video streaming, game streaming, live streaming. This is about education. This is about relationships. This is about health, work, surveillance, security. So everything now is video. And so now we have this super impressive adjusted forecast, a multi-billion-dollar market that is expected to grow at a rate of more than 20% up to 2027. So this is highly impressive. I feel that those numbers are huge. But when I look at these other numbers, then I feel even more impressed. So here they try to predict what's going to be the required bandwidth in our future homes, connected homes. And if you look at the areas here, you're going to see that most of them are related with immersive scenarios. So for instance, you need to have 167 megabits per second if you want to have HD VR at your home, right? So this scenario, this much awaited VR, MR experiences has been promising a significant rise in broadband usage for many years, much before the pandemic. So for instance, in 2019, video streaming was already considered and promoted as one of the main principles for the 5G technology, right? Why? Low latency, of course, higher bandwidth and higher speed throughput. So 5G is super connected to this new immersive world. So if you look at the 5G usage scenarios, for instance, most of them are related with immersive experiences. And it's not a coincidence that we are talking about this right now. 5G has been on the media for so many years, but actually only last year, the 3GPP, which is the standard organization responsible for that, was able to finally approve it, the final version of the 5G standard. And 5G is not only about smartphones or even video streaming. For instance, autonomous cars, the industry related with it, has already joined even the 5G licensing patent war. So there is so much going on, as I just said, related with video. And so I think that so far it's clear the amount of video that needs to be sent and stored, right, by the next years. It's going to explode, really. So in order to make it happen, we must look at this required ecosystem, right? So we must combine multimedia with communications, for instance. When you look at some of the applications for this new immersive world, for instance, robotic telesurgery, you must have low latency. By low latency, we mean less than 1 millisecond, right? Of course, we must have a faster network. So this ecosystem is composed of content, of course, so multimedia video, high-resolution video, 8K, 360-degree video, holographic video. It's composed of codecs. So as I said, I've been working with codecs for so many years, since the beginning of my master, then PhD, postdoc, and even now at Samsung. So from my point of view, the codecs are really the magic of the signal processing world. If you look at the numbers today with the current codecs, you can compress a video up to 600 times without noticing. So you, as a user, you were not gonna be able to see that the video undergone all this process. And in order to do this, we combine so many things. We combine statistical algorithms, we combine information theory, you can very deep understanding of the human visual system. So all of this has been going on for more than 30 years. So this is the work of so many people and so many years dedicated to evolution of the codecs. So codecs are very impressive from my point of view. We will talk a lot about this today. Then, of course, you must have the transport format. You must have the network, as we have just said, 5G, for instance. And then finally, the devices, right? So autonomous cars, smartphone, smart TV, smartwatch. And here I included, this one is very impressive, very much celebrated by the industry. This is the first one commercial dense light field display that was released this month. And I'm not sure, probably you know, people talk about this a lot, but the holographic volumetric displays like this, they are considered the real solution for this seamless reality blending, right? Of course, there is the cost of a huge amount of data that needs to be stored, compressed, transmitted, right? But this is, of course, one of the devices that must be included in this ecosystem, right? So I'm just talking about video because video is much heavier, but of course, audio and images are also included in this ecosystem. So usually when people talk about immersive word, they discuss these two ends, the content and the devices. So the device is expensive, the content is not good. But actually there is a whole ecosystem that needs to work in order for these technologies to work. And one technology that's fundamental for this is the multimedia standards. So this is, of course, a multi-billionaire market. And we want that all of those pieces should be able to connect. So if you have an international standard, or in this case, several, you will be able to ensure the interoperability of all of those super heterogeneous devices, systems, and video on demand platforms, and all of the companies that are involved on the development of these pieces of this ecosystem, right? So it's really important to look at everything in order to understand what's going on and why technologies have not been adopted, for instance. So since we're talking about standards, let's start with the most famous ones. I'm pretty sure you have heard of those, especially H.264, which is usually inside of MP4 format, right? So this started so many years ago, as I said previously, and usually those standards, they are done, the previous ones, right? They are done by three main standards organizations, ITU-T, ISO, and IEC, right? So that's why they have usually two names. So we had H.264 AVC, H.265 HEVC, and then the newest one, VVC, H.266. And the reason is because VVC, for instance, is the name of the standard for ISO, and H.266 is the name of the standard for ITU-T, right? So we will talk about this codecs a little bit during this talk. You remember this, right? H.264, then next the HEVC, and then currently VVC. So I like this picture because usually when people think about JPEG and Mpeg, they believe they are just standards, and actually they are not standards. They are groups that have been working together for 30 years. So when you look at these organizations, ITU-T, ISO, and EEC, the experts got together in joint technology committees and subgroups. So for instance, here we have the SC29, the one I just talked about at the beginning of my talk. And here you have JPEG. So JPEG actually means Joint Photographic Experts Group. And the joint is because it's a joint group from ITU-T and ISO. And Mpeg is the same. Mpeg, it's not related with ITUT. Most of it's coded. Some of them are related, but it means Motion Picture Experts Group. So they are responsible for so many standards, MP3, MP4, Dash, HEVC, so many others that we know about. And they have been meeting together 4 times per year in meetings that usually last like the whole week. And they have been responsible for the development of so many other standards. Not all of them became so famous as those that are included here, but there is a lot of work going on. So how does it work? I or anybody, we can't just go to a meeting and participate and propose our solutions. This must be done. There is a regulation. This must be done by countries represented by delegations. So in this case, in ISO, ABNT is our official ISO member. And for the ITUT part, it must be done by members represented by delegates. And in this case, for Brazil, Anatel is the ITUT member, right? So if you are more familiar with Mpeg and JPEG, you must have heard, maybe have heard, that Mpeg was over last year. And the reason is because last year there was a huge change for Mpeg, the biggest one probably in those 30 years. And the reason is because the group has become too large, and also there have been some issues after so many years working together. So they decided to actually split the groups. So now instead of one group, we have several. We have 8 and 8 ad hoc groups too. But they keep the name. In fact, the activities are going on. So you have video coding, audio coding, 3D graphics. We talk a lot about this. Genomic coding, technical requirements. Everything is still the same, but they just organize it in different ways. So if you have heard that Mpeg has, was dead last year, this is actually not true. So as I said, you can't just go there and participate. You must be part of a delegation. And actually, we, as Brazil, or as Latin America, we were not able to participate until 2018. So here in this map, you can see all the countries that are members, the blue ones, right? And being a member means that we are not only able to participate in the meeting, we are also able to vote. So this is a very important task, because every single standard must represent what is the decision, what is important for the countries, where it's going to be used. So now we are also able to vote. There are several ballots related to all the standards that are under development. And after we took some years to be able to create the delegation, I got together with several professors, got support from them. And then in 2018, we were able to finally create our delegation. And I was elected as the first head of this delegation. So now I am responsible for representing Brazil and what it wants in all these standards that are under development. Of course, we are not participating most of them because we are super small delegation compared to US and China, Germany, Japan, so many countries that have been there since the beginning. But still we are there, and we have been making some small contributions already. So in 2018, the first Latin America contribution to any JPEG standard was done by us in a standard that's named JPEG Plino. We will talk about this later. That was done by Samsung together with a collaborative project with a few universities. And we were also able to do the first Latin America contribution to Mpeg in a standard that's called MMT. And since then, the Brazilians have been participating and even assuming nice positions, relevant positions, such as JPEG Technical Committee, co-chair, chairs of other standards, and also leadership for some ad hoc groups. So as I said, in order to do it, we must be regulated by ABNT in our case. So we have a commission in Brazil, which is this one that is here. All the experts are welcome. So anyone that works in any related area that I will talk about today can participate. And I've been conducting 4 meetings per year, national meetings, but it's super easy. So right now I want to invite everybody that's interested. We can, of course, talk about this more late. So I said we would talk about 2 main topics, right? International standards and patents. And the reason is why those 2 things, they walk together all the time, right? So for instance, most of people, they don't have any idea about this. For instance, how much do we pay in our smartphones that's related to royalties, to embedded technologies. And in 2014, this paper tried to predict it, what was the potential patent royalties. And they got to this number, 30%. So this is a lot of money for a single device. And that was composed first by the cellular baseband chip, 3G, 4G, Wi-Fi, the video codec, operating system, and the audio codec, right? So actually, when people were taking a look at it, they said, look, this is not exactly true. We are not paying for all of those patents. The companies are not paying all of those patents. And the reason is why, and that was clear in this other paper, most of those companies, they engage in what is called the cross-licensing deals. So the reason why companies file patents, it's not just because they want to charge royalties. It's because they want to be able to cross-license patents. So they want to protect what they invented, not really sell what they invented. So this is the main reason why patents are filed and are so important in this world. And then also this other paper, also very important study in the area, they tried to say, okay, so how much is it? How much is it really that we are paying for royalties in a device? And they got to this number, more or less 3%. And of course, it's much less than the 3%. And this is a very important study because those numbers, they have been used not only to inform policies, but in many judicial decisions. So, of course, you have seen in the media all the time, big companies fighting for patents, like those are billionaire agreements. And when the judiciary system uses those numbers, for instance, then we have a problem, right? But this is only for you to have an idea about how this business of patents and the standards is important for devices such as regular smartphones, right? So then let's take a look at the codecs itself and how it works on each of them. So I've just showed you first codec that was, and this is still the main one, H.264, was completed in 2003. So this is a lot of time ago. It's still the main one. And so when the companies that developed this codec got together, they were able to collect more or less 1,000 patents. And they were able, there are so many companies, you can see here, most of them, all of them are famous. I'm pretty sure everybody has heard of all of them. And they were able to get together and reach an agreement. So they got this patent pool called Mpeg LA, and they decided, okay, this is how we will charge for the H.264. Everybody agrees, and this was a huge success because if you want to use H.264, you can just approach Mpeg LA, for instance, and you know exactly how you have to pay for it. So there's no risk you're going to be sued later for some patent that you haven't paid for. So this is charged for encoder, decoder developers. This is charged for patent content distributors that have subscriptions. This is paid for broadcast TV, for live streaming. So for everybody that uses the codecs in so many different ways. H.264 is still the preferred codec today. So if you go to YouTube, for instance, to upload a video, they will tell you, please encode this video with MP4 inside H.264. And this is pretty impressive for a technology that's from 2003, especially because there are other options. So in 2013, we had HEVC. So 10 years later, HEVC is much more, it's better, you have higher compression, it supports 8K, and it was not adopted as they were expecting. So let's see why. So first, I will invite you to guess a number. So here is the block diagram for the HEVC. I will not explain all these topics. It's not required. But you can see that here you have transform, quantization, loop filters, everything is here. So try to imagine how many patents are here in the HEVC technology. Remember, for the H.264, we had around 1,000. Try to imagine how many patents companies were able to fill out 10 years later, considering all the increase in the interest of video and everything that we saw before. So the thing is that these companies, here are the main companies with patents. Most of the patents are legacy from 8 to 64. Not most of them, 30% of them, but it's a significant percentage. And this is how the industry works in video coding. It's always an incremental advance. And this is because you must have hardware support. Of course, companies are interested in using their patents, but it's also because the design of a video codec, it doesn't change a lot for one codec to the other. And so what happened was that the companies were not able to get together this time. They were actually more or less able to organize themselves in 3 different patent pools that are here. And several companies were not affiliated to any patent pool at all. So if today you want to use HEVC, you actually will have to approach each one of those patent pools and each one of those companies individually to know how much you have to pay for their patents. So this is a huge problem. Companies that want to use HEVC, they feel insecure. Of course, it's much more expensive and you have a higher risk of being sued later. So this is the situation from last year. I asked you to guess how many patents. So 17,000 patents are now in the HEVC. So if you look at one of the patent pools, only this one has more than 10,000 patents. And not all of them are considered what we call standard essential patents, but most of them are, right? So this is a huge number of patents and a big problem for the HEVC technology, okay? So when you look at this graph, you see, for instance, how many patents have already been granted per year for the 10 main companies. And here you also see the geographic distribution for those patents. So you see that, of course, most of them are in US, China, Korea, Japan, but you also have some in Brazil. So I included this slide because I wanted to say, for those of you that think that this is not our problem, last year we already saw some judicial IP disputes over standard essential patents of HEVC, including big companies. Many professors in Brazil acted as consultants for both sides, and that was done here in Brazil from patents that were filled out for these companies more than 10 years ago, but have been already granted by our INPI. So this is also going on here in Brazil right now. Right, so HEVC had this big problem, but people didn't give up. And VVC is already here. So VVC is the newest codec. It was completed last year. I included those 2 pictures. Those 2 pictures, I took those pictures from my first Mpeg meeting in 2018. That was the meeting when the companies were responding to the call for proposals. And I was very, very impressed because, you know, these meetings, as I said, they stand for the whole week. It was more or less 10 p.m. and the room was packed. And here are like most of the people that worked the papers that I was studying when I was a PhD student. So, and they are still there. And there was a huge interest, even with the problem that happened at first with the HEVC. So VVC is also a huge success, was able to compress more 50%. Of course, there is an increase in the computational complexity, but this is very related to what we are talking about today, immersive words. So 360 video, immersive XR, telepresence, low latency cloud gaming, 8K video. So everything you can imagine is here. It was included and it's supported by the VVC. Not everything, but most of the scenarios, let's say, right? And this is, I included this picture because this is the magic I talked about first, right? So let's talk about a full HD video, right? 25 frames per second. So this uncompressed means around 1.2 gigabits per second. So in 1994, here, when the first codec came up, they were already able to compress it by around 70 times. So it went from 1.2 gigabits to 16 megabits. After all those years, 25 years, right? Several people working, several thousands of hours. Now, with the VVC, you are able to compress the same video to only 2 megabits per second. So this is more than 600 times. So this is more or less the evolution of the codecs over all of those years. And I think it's really, really impressive. Well, of course, that VVC is also here with its patent pools, the same problem with HEVC. It's starting, right? They were able, not all companies were able to speak what they want so far, but they were already able to select 2 pools. So it's sure we will not have just 1 pool, it's 2 pools at least. So some of the companies involved are here. And this is, I think this information here is very interesting. First, because you can see that what are the most the companies that are most contributors for this technology and how it changed from HEVC to VVC. So we have Qualcomm, Huawei, we have ByteDance. ByteDance, for those of you who don't know, they are the owners of TikTok, right? And we see so many other Chinese companies that were not here before. And other thing we also see are companies that were very much involved in the HEVC, such as here, Samsung, Microsoft, Sony, and that are not so much involved with VVC. And the reason, many reasons, patent problems, but also one reason that I will show next. And the reason is that there is competition, right? So we call it competition in a polite way, but maybe we could call it's a codec war. So back when the HEVC was starting with these problems for the patent pools, some companies, they got together and said, okay, so let's try to make a royalty-free codec, right? So currently we have all of those options and they are making a lot of noise. We don't have only options with Mpeg. So let's look at some of them. So just to mention, I'm not sure if you had a time because the slide was super fast, but maybe you noticed that most of the new companies that are very much related with video, they were not there. So for instance, Amazon with Prime, Google with YouTube, Netflix, Facebook with WhatsApp, Instagram. And the reason is because these companies are new. So 30 years ago, they were not there. They don't have this standardization patents. So they actually had to use those standards and to pay for the royalties. So they got together and tried to say, first Google was the first one. So they started with VP8 in 2008. They tried to promote it as a free alternative, but actually, as we said before, it's super tough to do a codec from scratch without infringing any patents. And so actually Google later started to pay license fees for the Mpeg LA to be able to promote VP8. Then 2012, they tried again with VP9, the same problem happened. And besides that, they didn't have much support. So for instance, Apple was not supporting the technology, so you couldn't watch 4K video on Apple TV or your iPad, for instance. And then finally, when we had the HEVC problem patent pool, several other companies got together and they said, okay, so now let's found what they call the Alliance for Open Media. And they come up with a codec that then was not supported just by one company, but several, which was named the AV1. So AV1 is available since 2018. And it's a nice codec. Has been calling a lot of attention. It's compared to AVC, for instance. And for instance, Netflix is already streaming AV1 videos since last year. And here the difference is that if you take a look at the companies that are involved, you have several others. So, and in all the areas, so you have browsers, you have content providers, you have chip producers, you have mobile companies. So Amazon, Google, Intel, Samsung is also here, Mozilla, Google, Amazon. So it's a big alliance, and they tried to come up with this AV1 as a free, royalty-free option. And some people say, super fine, if they can survive the legal challenges, probably they will change the industry forever. And this royalty-based codec development history of 30 years will be over. And others say, nice, but what they are trying to do is quite impossible, because this has been done this way for so many years. And so many companies have invested money on this. And it's very tough to really design a codec from scratch. And if you take a look at AV1, actually it follows more or less the same structure. It's a hybrid codec. You have all the blocks. So it was not a really surprise when this company called Cisco It's an intellectual property license company. Got together some companies that were owner of some patents related with AV1. Right now, they have more than 1,000 patents, and they are now um, they now have a license fee for the AV1 that should be a royalty-free codec, right? So this was not a surprise for most of the industry, but what they are trying to do, if you take a look here at the companies, you will see that they're very famous companies, Adobe, Ericsson, Toshiba, InterDigital, SK Telecom, GE. And so those are the companies who claim they have these patents that are infringed by AV1. And what they are trying to do is that every time they try to find a patent that has been infringed, they invite the company to join the alliance, because they have this agreement that the companies inside of the alliance, they will not sue each other. So several companies, they are in Mpeg and they're also in the alliance. So Samsung, Cisco, Google, Microsoft, several of them are in both patent pools. So they will not fight over these patents. But some other companies, such as those ones that are here, they were not interested in joining the alliance. So we will see probably a lot of fighting over those patents. Currently, we don't have extensive support. So for the newest chips, for Samsung, they already support AV1 decoding. You have support in some TVs, especially for 8K. This is, of course, interesting. But other companies such as Apple, they don't support it yet. Even though they say they will, they have not done it yet. So it's something very new for AV1, and we will see what's going to happen. So here we have the latest picture for the mess of the HEVC, now including these patents that those companies claim that have been infringed. So those are the patents from the HEVC that those companies say they are also related with what AV1 did, right? So this is the current situation for all of those technologies. But this is not enough. There is more competition, internal competition at Mpeg, right? So this is something very interesting that happened. As I said, for instance, companies such as Samsung, that they were not so much interested. They were interested in VVC, but they are also interested in something else. So when the call for proposals for the VVC was done in 2018, these companies, they proposed a codec that would have a royalty-free baseline profile. So if you have just a basic codec, you don't pay. They ensure this is not infringing any patents because we're just using technology that is patents that have been already expired. And if you want something else, then you have some switchable enhancements. Then you just pay for the enhancements, and they would say exactly how much you would have to pay. So this it has been promoted a lot. It's called the EVC. It was done finalized last year. It's 25% less than HEVC, similar to AV1, roughly half of the complexity of VVC. And they claim that they will say what is the license terms by next year. So this code that has been considered for many other standards. And the last one is the LCEVC. So this one has been also considered, also finalized last year. And this is actually what we call a codec agnostic tool. It means that you can use any codec as a basis, even if you want, or H264, whatever you want. They just proposed this base stream and enhancement bit stream. So they have this idea of scalability, and they have actually already announced what are the license fees. So people are already paying attention to this codec. So I wanted to show you all of those options and to talk about all of these patents, because we discussed at the beginning why are the reasons why so many technologies are not adopted or not. And here you can see clearly that it's not because of the technical aspect of it. Actually, the AVC got an Emmy award. And this picture is so nice. Here you can see the people that are here are the real researchers and developers. So here you see that have been working on this for like 30 years. You see people from Intel, Samsung, Microsoft, Ericsson, Qualcomm, Fraunhofer. You see that those are real, the people that I talked about that wrote the papers, and they got the Emmy for the technology. So the HEVC was a very nice technology, good technology, very nice quality, even though it was not able to be adopted as it was expected because of this problem with the patent pools, right? And here you also have the JPEG. JPEG also got an Emmy. Actually, most of those technologies have been awarded, and even though not all of them have been adopted. And so this is the current situation. We are here in 2021, almost 20 years later, and this is the adoption of H.264, huge. This is a search for last year, and they asked companies what they were planning to adopt for the next year. So they said, okay, we are planning to adopt AV1 and even HEVC, but even though HEVC is still the dominant technology. And the reason is, of course, the lack of proper patent pools, but also because these new technologies, they are more beneficial, for instance, for high resolution content for 8K, and 8K, it's not believed to be soon for everybody, and also because people are consuming a lot of video on smartphones. So for smartphones, you don't need to go to those higher resolutions, and HEVC is just good enough, right? So this is the situation so far, but what is expected is that with 5G, we will finally have all of those immersive scenarios, devices, everything else, and H.264 is not able to support it. So the industry expects that this scenario will change soon with the arrival of those immersive content. Right, so before we finish, I want to talk about the Brazilian participation. This is really nice. As I said, we started to be able to collaborate with our proposals in 2018, and we have been able to contribute mostly in these three standards, MMT, JPEG Plano, and PCC. We just have one company participating, Samsung, and two university groups that are here. And we were able to see that it's not a lack of interest or competence. It's really a lack of money. So we must have more companies, especially private investments. If we are able to do this, we know that we will be able to increase a lot Brazilian participation. And this is important because if you look at Netflix numbers, for instance, currently Brazilians are like number 2 in the world. So we are huge customers of this type of media. We must be able to produce these standards as well, not only to use them, and to produce them in a way that's beneficial for us, according to the country interests. So now we are able to do this. As I said, very small participation yet, but hopefully it will increase. So I will talk mostly now about these two standards because we haven't discussed them. They are very related with this immersive world, and those are the standards that we are participating and that we have participated in the past. So here is the JPEG family of standards. I just said previously, right? JPEG is not just one standard. Look how many others. And this is the JPEG Plano. Plano comes from Planoptic, because this standard, it was designed to be actually a framework for these three types of formats: point clouds, light fields, and holography, right? So we were able to contribute on the compression of light field images, which was the first activity. And we collaborated a lot. There was a lot of work done by Brazilians in all the parts of the standard, especially in those parts that I have highlighted here. So we were responsible for the conformance testing, for the reference software. We did a lot of work with the part 2 in specifying one way of compressing this type of technology. So I would say this is so far the standard that has that we were able to really participate, and it was finalized last year. We still don't have devices that can take pictures with light fields, but hopefully when we have them, people will be able to use this standard, and you will know that it has been made with a huge contribution of Brazilians. And the other standard is the VPCC. It's related with point cloud compression. And here we just arrived in the end, so we know that they have been working since in 2014. And in 2017, they issued the call for proposals. And so when we arrived here, in the end, we were able to make a very small contribution, but still was very, very interesting. We were able to learn what it is. And the PCC is actually divided in two different codecs. One is called the video-based VPCC, and the other is the geometry-based GPCC. And it depends on the type of point clouds. It's sparse or dense or the application. The compression that it can be achieved right now, it's already impressive, 100 times to 300 times. And this is how it is encoded. So the 3D point clouds, they are actually encoded as a set of 2D videos. So there is this projection phase. And that's why you can actually use any codec that you want inside of it. So you can apply HVC, AVC, or even VVC or EVC, any codec that you want. So this standard, as I said, has been finalized last year. So there is a lot of expectation for its adoption soon. It can, of course, provide several immersive experiences, 6DoF, everything. And we were able to start our contributions in October last year. And several Brazilians have been working even today and making contributions for other areas of the PCC. Not only the VPCC, but also the GPCC. And I also wanted to show this picture because when we talk about a standard, we discussed VPCC, VVC. A standard is not only, when we talk about video, it's never alone. It's also part of a bigger standard. So for instance, in 2018 and even before, the Mpeg came up with this idea of the Mpeg immersive standard. And they decided to have all of those parts. So if you look at these parts, and this is always how the standard is done, you're going to see the VVCs here. So VVC is actually a standard inside of the immersive standard. So you're going to see the audio coding, immersive audio coding, point clouds compression. You're going to see other technologies for supporting the streaming, formats, everything else. So that was the plan in 2018. PCC is here. And this is how it looks today. So you saw that from 2018, the standard had 8 parts. Today, the standard has 26. So most of those parts are related to reference software, conformance testing, but there were some changes, important changes. So one of them is that the Mpeg immersive video codec was introduced. This is very nice, so much related with dense light fields and other technologies like that to provide 6DoF. And then because of that, the VPCC was actually, it became something bigger that was called the V3C, the Visual Volumetric Video Based Coding. And now the VPCC is a small part of it, not a small, but a subset of it. And the GPCC is also included here. So now we have this biggest, when you learn about this, talk about this, we have this bigger codecs called V3C. VPCC is a part of it, as well as MIV. All of them related with immersive encoding and technologies like that. And so just before the end of the talk, I wanted to show you what's going on in our Brazilian forum for the digital TV system. So I'm not sure if you know, but the discussions for the TV 3.0 have already started, and they are actually requiring support for immersive content. So VR, AR, XR, 6DoF, 3DoF, it's there for our next TV standard, and also scalable video. So they have launched the call for proposals. They have received the responses already from 21 different organizations. And I have highlighted here the codecs that have been proposed for all of those systems, the ones that are related to our talk today. So for instance, MMT has been proposed for the video coding HEVC, LC, EVC, VVC, and for the VR coded the VPCC. So what's nice here is that for the previous Brazilian digital TV system, for instance, we were not producers of any of those codecs. We're just selecting. So now we are selecting, but we are also part of them. So of course, very small part of them yet, but it's very nice to know that this technology, they are on the table. And right now what they are doing is that they are testing and evaluating all of those technologies. And this has been done by 7 different Brazilian universities that are here. Each one's responsible for one component, system component. Of course, we have more than video coding, etc. And if everything goes fine, we should have this new digital TV Brazilian system operating from 2023. So I wanted to show these last 2 slides here. And the reason is why when we started the talk, we were saying what goes on in the industry, what's happening, what's going on, what's going to be the adoption for this immersive world. And we saw that there are so many things involved, communications, standards, and patents, not only devices and content, but this roadmap is something that I believe it's very useful and has been done by Mpeg for so many years. So this is the roadmap that I saw when I joined Mpeg back in 2018. And you can see that some things were already here. For instance, here you have the new video codec. Didn't have a name yet. This now is the VVC. So everything that they had planned here, light field coding, PCC was already here, 6DOF application format, genome compression, 6DOF audio coding. So if you had access to this roadmap back there, you would see, for instance, that we would not have any device related with point clouds before 2021, because the standard would not be ready yet. Of course, 5G is also related, but this is the plan that the industry follows, right? So this is very valuable information for everybody that's trying to predict the future. Of course, I'm not saying that everything that's here really happens. I'm just saying that several companies, and really several, you saw the names, they got together every year, every meeting, to try to come up with this roadmap and try to have an agreement. And there are several meetings that are called requirements, where people try to define what we will use, what will happen, how, what are the interests that will be the strongest. So as I said, this was the roadmap from when I joined it, and this is the roadmap from today. I got this from the last meeting. And as you can see here, most of the codecs we talked about are here. EVC, LCEVC, the MIV. You can see that here people were talking about AI-based video coding. You can see that you have so many other things going on. Video coding for machines. This one, for instance, is super interesting. So what happens if the user, it's not a human, it's a machine? So what are the quality metrics? What are the bit rates? So there are so many applications today that are done for machines, not real users in the end. So this is included here. Haptics is here. Genome compression is here. So if you take a look at it, I think it's, again, very valuable information for those who are trying to figure out what to do and what's going to happen and what are the years here that companies are considering. So I invite you all again to join the committee, to join our delegation, so you will have access to this information and others. And I actually added one last slide this morning because I saw this email this morning. And this is the invitation for a workshop that has been organized by JPEG and Mpeg, Emerging Activities. And it's going to be next week. And so look at the topics. I think they are very interesting for this community. AI-based coding. So neural network video coding for machines, point cloud coding, JPEG Plano, mesh coding. It's also a new topic. Light field coding. So it's going to be given the talk by a Brazilian, Professor Eduardo from Federal University of Rio, which is became a big contributor for JPEG. Mpeg lenslet video coding. So for people that are working in this field, I believe that having the chance of participating in a workshop like this, for instance, it's very interesting. Very valuable information is usually shared in these workshops. Okay, so I will finish with this slide, and I would like to thank the invitation again, and also congratulate all the organizers for such great event. And here is my contact if you want to know more about the delegation, about standards, or anything else, just get in touch. Thank you all.
Thanks, Vanessa. It was really, really nice talk. It was really mind-blowing for me because you bring so many information, not only technical information, but also the backstage of what's happening
Exactly.
in this kind of industry. So it's thanks very much. It was really enlightening for me. I have many questions.
Wow.
But yeah, maybe it will be more a discussion. So I
I
would
see.
I will first encourage people to ask questions on our YouTube chat. And I will start with one question here. We also have Emilio that can ask questions if he wants. But my first question would be why why do you why there is this huge amount of patents related to a single codec? But from my point of view, of course, I would say I guessed 1,000 patents, but then how do people do that? Because if it's you design some codec, then is it possible to change just part of it and it becomes a patent? How does it work?
Yes. This is an interesting question because we had 1,000 patents, but for HVC you saw 17,000 patents, right? And so first you have to keep in mind that there are so many companies, 50 companies working on this, and that when you look at the blocks, the diagram, it doesn't really show all the complexity of the codec. So, for instance, when you just talk about the transform, there are so many ways to do it, or the prediction, the interprediction, the interprediction. So there are so many things that are proposed, and it's also interesting to talk about how it is done. We didn't talk about this, but it's interesting, I think. So when you go, so let's say you are working with your team in the interprediction. So you have some proposals, right? And you go to the meeting. You actually have to present your results in a very fixed way. So you have to present your results in this specific metrics, in this data set, and the other companies will check your results. So we have what's called cross-checker. So when you are at the meeting, the decisions are made based on the metrics. So objective metrics, subjective metrics. Then let's say they came to the conclusion that your technology is better than the others. So your technology will be included in the standard, right? And the others will not at that specific part of it. This is what is done in the meetings. And you have to keep in mind that this process takes like 5 years. So people go to the meetings 4 times per year, but after when they came back to these companies, this development continues. So you have teams of like 100 people working at each one of those companies. And then you have like 10 people who really attend the meeting, those people that you saw in the room at 10 p.m. at night. And then when the codec is ready, when we are at the meetings, people don't talk about patents. There is no patent discussion. Nobody talks about it. When the codec is done, then the lawyers from those companies, they get together the patents. And then they say, okay, those are the essential patents from my company. I want to charge X for those companies. And then the lawyers try to get together with these other companies to build these patent pools and to figure out how they will charge for the royalties and everything else we discussed today. So this is actually a very frustrating process for the experts, for the developers, for people that are working on the development of the codec, because they work like 5 years. They got an Emmy for the codec, and then in the end, it's not you can't use the codec because the companies, the lawyers, were not able to achieve an agreement. So
Yeah.
this is something that has been criticized for many years at Mpeg. And then you saw when I mentioned EVC, for instance, which is a totally new approach. It's like, okay, we will start from the beginning to talk about patents. So we'll say from the beginning, we are proposing this baseline that's royalty free. We know that there are no patents. And then we have this enhancement profile. Then we have patents. And this is how we will license the patents. So uh, this is how in the end you have so many related patents. Don't forget that many of them are legacy, right, from 30 years before. And if you look at the development of the codex, if you look at the how is the block diagram for the HEVC, for the EVC, you will see what are all of those technologies. So if, for people that are really interested on this, because VVC is a new codec, in our conferences, people are always giving talks about VVC explanation. So for people who are interested, I really recommend it, and you will be able to see how much work can fit in a codec. It's really impressive.
Cool. Yeah, yeah. I had no idea, and I heard about, for example, AV1, which was intended to be like more. Uh, I remember Mozilla was involved in some for some
Yes.
reason because they are a company that's interested in having open source stuff. So yeah, and it's interesting to hear that the, the difficulties that people may have when trying to implement such royalty-free codecs. Yeah, I have one comment here from Gastal. It was also one of my questions. Do you think those codecs may really benefit from machine learning approaches, or that those would?
Totally. They have already been benefited. So even at this CiviGraph, we do have a paper, Samsung, together with UND, about applying machine learning for an end-to-end codec. And what we have seen already are some blocks of it. So for instance, the filter, the prediction, where people are already applying machine learning techniques, but we don't have yet at Mpeg, for instance, a codec that it's end-to-end done. So, machine learning. What we have is that inside of some of the blocks, people are applying it. And if you think about it, compression has a lot to do with prediction, which is very related with machine learning. So what is also interesting is that for all of those codecs, we don't have recognition, right? So you are not encoding any specific content, even though we have classes. We classify the content such as, oh, this is a high movement. This is a game, and this is the news. So this is the nature. So it changes a lot. Or this is a cartoon. So it changes a lot the performance of the codec, but you never really recognizes what is there. And I know this is very different from what people from the machine learning area are used to do. But the reason is because you can't have a codec that works just for this type of, content where people are there. So you must have a codec that's able to be applied for any type of content. So Netflix is gonna apply it for all the videos that they have, and it's gonna, send the videos to the consumers, and they just change the resolution. They change lots of things depending on your bandwidth. So there are many things to try to improve the quality of your video streaming, but there is no content recognition. So machine learning is applied for prediction, is applied for better. So this is also very important. We have quality metrics now that are using machine learning techniques to trying to improve it, especially from the subjective point of view, which is many times different from the objective metrics that we have. And so you saw, I show it in the roadmap, this activity AI video coding. And this is something, but there is also AI applied in other parts of it. So video coding for machines, they are applying AI. several others. So there is no doubt that machine learning is going to be important for compression.
And does it overcome or reduce the patent problem, or it's just the same?
That's a good question. I don't think people got there yet, but I really doubt it. I think that the patents will be there.
Yeah, so there you go, Gaston. All right, so Emilio, do you have any questions?
Yeah, I will get one from the audience that Iago asked about the. It was specific about who have academic experience with codecs and how the companies see that, how the companies willing to hire someone with only academic background. But I can say that could be a general question. Suppose you have a very good PhD student or that give his academic on a very specific area like codecs, how the big companies see this kind of professional and how
Okay.
could be the process to hire someone like this background.
So the short answer is great. It's just for you to have an idea. 100% of my team has a PhD. And so I can talk from the Samsung point of view. Of course, I can't talk for all the companies in Brazil, but what I see outside, so let's talk about this, outside of Brazil is that PhDs, especially when we talk about this work, the codex work, those people that were there, proposing things, I would say, I don't know, 80%, 90% of them had PhDs. So, and one of the reasons is because this type of knowledge, it's not, you don't learn it in the undergrad studies. So usually, even in the universities, not only here in Brazil, but also outside, you are gonna learn this type of stuff in the master, in the PhD. So this is something that requires a lot of learning and effort. So what I see is that in this area, there are many, many PhDs in the industry and also here in Brazil. But here in Brazil, talking about Samsung again, I see that PhDs are very welcome, not only in my team, but also in the other teams. So in the AI team, for instance, and it's really tough to find people in this field right now. Of course, it's a super hot area, and Samsung is even hiring undergrad students right now, and training them because it's really really hot. So I don't know if it is because, for instance, I had a PhD. So people who had PhDs, of course, they see it in a different way because sometimes people believe that PhD, just study for 5 years. And actually, it's not. Actually, you are building something new in the world, and your work it's going to be very much related to the work in the industry later, right? So you will have to prepare talks, you will have to prepare proposals, you will have to present your ideas, you will have to present your ideas in an organized way. So the PhD will give you so many more skills. It's not just learning about some technicals. It's not just study, right? So people that are in the PhD here, they know about this, and the people that are in the industry know that as well. So of course, as I said, this is my point of view, what I see at Samsung and other companies in this area. I'm not sure it's not the position of everybody, of course, but I would say very, very welcome.
Thanks, Vanessa, for that.
Fantastic, thank you.
But we don't have
Yep.
many positions, right? Yet.
Yeah,
So, so
that's
this
true.
is a very big problem. As I said, we have very, very few companies in Brazil investing on this, and less. So the situation is it's really bad.
Yep.
So it's welcome, but we are not really in the position of really developing super innovative technology. Most of the companies in Brazil right now, it's very tough to find this type of work here, this type of position of possibility. But when I give talks to students, what I say is that you don't have to look for the Brazilian market. For this type of knowledge, you have to look at the world. So what you learn here in the universities that we learn here, it's gonna be good enough for working anywhere. in the world. So this is what they have to keep in mind. So if you are looking for a PhD, go for it, and don't be restricted to the Brazilian market. This is not how you should look at it.
Thanks,
Great.
Vanessa.
From the point of view for IBM research, is the same, and we have here a research lab as well. Then, yes, that's a huge problem. And I agree with exactly what you said. That's it's important to have PhD for some positions. It's hard to find the right, but normally the Brazilian universities are really good, and we can go for the world. Thank you, Vanessa.
Good. I have just a last question. I was curious about why there is a genome compression in the same pool as multimedia content.
Yeah. So if you take a look at how they were talking about these requirements in the last years, they were saying compression is something that's required not only for multimedia, but there are so many other areas in the world that also require compression. And then genome is one of them. So they started this group, and then they actually now the scope of the Mpeg or the SC29 as it's called right now, it's not only multimedia, it's data in general. So it's called data compression. So it's audio, video, images, genome. It's anything else. They had one activity for something related with the industry, for instance. So any type of data that needs to be compressed, stored, sent, that must have international standard, for instance, is welcome right now. And actually, this genome activity has been ongoing for several years. It's not even something new. If you look for the roadmap in 2018, it was already there.
Yeah, I was surprised to
Yeah.
even it. All right, let's see if we have any other questions from the audience. Well, many people congratulating you for your talk.
Thank you.
Emilio, do you have any other questions?
Several, but I believe I can do that offline because we are on top of the hour.
Oh, okay. Yeah.
I'm very curious for other point, but I will send an email to Vanessa asking. And let's
Very good.
keep.
So, Vanessa, thanks very much for your talk, for having taking a little bit of your time to being with us. I already admire your work and your career, and I think after this more close contact, I became a kind of a fan. So thanks very much.
Oh, but don't say that. I really appreciate it, and I'm very sad now. But as I said, when I thought about this talk, I said I need to prepare something that's first interesting for everybody, and something new that I know that people usually don't have access to this information the same way that I didn't have before I started. So I believe that starting the delegation was great. Being able to contribute as the head of the Brazilian delegation has also been great. And I really hope that this can help the Brazilian community as a whole. You see, I see this as a big potential for the future of everybody, professors, the industry, the students, everybody that's interested. So hope to see you there.
Thanks very much. I think you can wrap up.
Bye-bye.
Any final words, Emilio? No. So
No, just thank you. And second, what you said, that it's amazing work and was amazing talk. Thank you so much for your time.
Okay, so now we have a break